Good morning, everyone. Welcome to today's session. I'm excited to introduce our topic, Grade 8 Integrated Science, Practical Paper 2, Term 3 Opener. Today, we'll be taking a quick look at what you can expect from this paper, including the key areas you'll need to focus on. We'll also go over some tips to help you prepare effectively. So let's get started and make this a productive and engaging session. Welcome to Slide 2. Here, I want to walk you through some important instructions for your assessment. First, make sure you write your name, your assessment number, and your school details clearly on the paper. This helps ensure your work is correctly identified. Next, don't forget to sign and date your assessment paper. This is crucial for validation. It's also important to answer both questions provided, and do so in the spaces allocated for each. Be careful not to remove any pages from the paper, as this can cause issues with your submission. And finally, remember to answer all questions in English. Following these guidelines helps keep the process smooth and fair for everyone. These instructions are designed to ensure your assessment runs seamlessly and that your work is properly recorded. So, pay close attention to these details as you proceed. All right, let's take a closer look at question 1, which focuses on the electrical circuit setup. First, I want you to identify components C, D, and E. Think about their roles in the circuit. Are they resistors, switches, or perhaps some other element? Recognizing these parts is key to understanding how the circuit functions. Next, consider what happens when component B is closed. When we close a switch or complete the circuit at B, it allows current to flow through the system. This action can turn on a light, power a motor, or trigger other responses, so it's essential to grasp the impact of closing component B. Finally, the question asks us to name the form of energy flowing through the wires. In most electrical circuits, the energy moving through the wires is electrical energy, which can then be converted into light, heat, or mechanical energy, depending on the components involved. Connecting this to our overall theme, understanding how these components interact helps us see the fundamental principles of electrical circuits, how energy flows, how components control that flow, and how we can manipulate it for various applications. So, keep these points in mind as we analyze the setup and work through the questions together. Let's talk about some important electrical safety precautions to keep in mind. First, it's crucial to avoid handling electrical appliances with wet hands. Water and electricity are a dangerous combination, and even a small amount of moisture can increase the risk of electric shock. So, always make sure your hands are dry before touching any electrical devices. Next, be careful not to overload sockets. Plugging in too many devices into one outlet can cause overheating and potentially lead to fires. It's better to distribute the load across multiple outlets if needed, and never force more plugs into a socket than it's designed to handle. Lastly, always ensure that wires are properly insulated. Damaged or exposed wires are a serious hazard because they can cause shocks or sparks. Regularly check cords and wires for any signs of wear and tear, and replace or repair them immediately if you notice any damage. By following these simple but essential precautions, we can significantly reduce the risk of electrical accidents and keep our workplaces and homes safe. Remember, safety always comes first when dealing with electricity. Let's take a look at energy transformation in appliances, using the electric iron as an example. The main energy change here is from electrical energy to heat energy. When you turn on the iron, electrical energy flows into it, but what we actually feel and see is the heat energy being produced. This heat is what smooths out your clothes and removes wrinkles. The key point to remember is that electrical energy is converted into heat energy in this process, which is a common way many appliances work. Understanding these energy transformations helps us see how different devices operate efficiently and also highlights the importance of managing energy use wisely. All right, in this practical, you're given a few simple objects: a small piece of wood, a copper wire, and an iron nail. Now, the first question is, which of these is magnetic? Well, the answer is the iron nail because iron is a magnetic material, meaning it can attract other magnetic objects. The wood and copper wire, on the other hand, are not magnetic. The second question asks us to state one property of a magnet. One key property is that a magnet can attract certain materials, like iron, nickel, or cobalt, without actually touching them. This is because of a magnetic field surrounding the magnet. Connecting this to our overall theme, understanding what makes an object magnetic helps us explore how magnetism works in everyday life and in various practical applications. So remember, the most important concept here is that magnetic materials are attracted to magnets due to their magnetic properties, which we'll see in action in this experiment. Let's talk about some real-world applications of magnetism. One simple but important example is a refrigerator door. You'll notice it uses magnets to stay closed securely. Essentially, the magnets attract a metal strip on the door, creating a strong, tight seal. This is a practical use of magnetic attraction that helps keep our food fresh. It also highlights how magnetism can be used in everyday life to solve simple problems, like ensuring doors stay closed without additional effort. This example ties back to the overall theme of how magnetic forces are all around us, often working behind the scenes to make our daily routines easier and more efficient. Let's talk about the fire triangle. This concept is fundamental in understanding how fires start and how to prevent them. The three components are heat, fuel, and oxygen. Think of it as a simple but powerful model. Remove any one of these elements, and the fire can't sustain itself. Heat is what ignites the fire initially, like a spark or a hot surface. Fuel is what the fire burns, such as paper, wood, or gasoline. And oxygen is the air we breathe, which supports the combustion process. Now, when we look at common causes of fires, two major ones come to mind. Faulty wiring is a big culprit. Imagine worn-out or damaged electrical cords that can generate heat and ignite nearby materials. Unattended cooking is another frequent cause. Leaving pots on the stove without supervision can quickly lead to a fire, especially if there's combustible material nearby. Understanding these causes and the fire triangle itself helps us see how fires start, and more importantly, how we can prevent them by controlling these elements. Whether it's maintaining electrical systems or staying attentive while cooking, it's all about breaking the triangle and keeping ourselves safe. Now, let's focus on the arrangement of particles in B, which is the liquid state. In a liquid, the particles are close together, but unlike solids, they are not in a fixed position. They can move around each other, which is why liquids can flow and take the shape of their container. This movement allows liquids to be somewhat flexible in their shape while maintaining a definite volume. Next, let's talk about two important processes related to states of matter. First, we have boiling, which is the change from a liquid to a gas. This occurs when the liquid is heated to its boiling point, causing particles to gain enough energy to escape into the air as vapor. The second process is condensation, which is the opposite. It happens when a gas cools down and the particles lose energy. As a result, they come closer together and form a liquid again. These processes are essential to understanding how matter changes states, and they play a significant role in many natural and industrial processes. So, recognizing these processes helps us understand the behavior of different materials under various conditions. Now, let's look at diffusion and pressure. Diffusion is all about how particles move from an area of high concentration to an area of low concentration. Think of when you spray air freshener in a room. At first, the scent is strong near the spray, but over time, it spreads out evenly throughout the space. That's diffusion in action. It's a natural process that helps particles distribute themselves evenly. Moving on to pressure, this is where the SI unit comes in. The standard unit of pressure is the Pascal, abbreviated as Pa whenever we talk about pressure in physics or engineering. We're referring to how force is distributed over an area. Understanding pressure is key because it influences many phenomena, from how fluids behave to how our lungs breathe. So, in the bigger picture, diffusion and pressure are fundamental concepts that help us understand how particles and forces interact in the physical world. They're essential for explaining everyday processes and even complex scientific systems. Let's wrap things up with some key takeaways and revision tips. First, it's really important to understand each practical step thoroughly. Don't just memorize, but make sure you grasp what each step involves and why it's necessary. Next, always observe the setups carefully. Pay attention to the details, as this will help you replicate procedures accurately and avoid mistakes. Safety precautions are crucial, so make sure you apply them diligently at every stage. Safety is always a top priority. Finally, revising key definitions and diagrams will reinforce your understanding and help you recall important concepts more easily. Remember, by focusing on these points, you'll strengthen your overall grasp of the topic and be better prepared in real-world applications.